This is a recording for section 11.7, events involving and, as well as conditional probability. And probabilities with independent events. And in probability implies multiplication, right? So anytime you see something and something, you should always think times. Of course, or, which we studied in the last section, implies to add. If we want the probability of event A and event B, we have to make sure that the events are independent, or we have to take into consideration that one event depends on the other. So two events are independent if the occurrence of either of them has no effect on the probability of the other. For example, if I have a bag of balls and a tub of say dice. If I want to randomly select a ball out of one tub and randomly select a die out of the second one, pulling the ball out of the first one has no effect on which one I'm going to pull out of the second one. So those are actually independent events. So with independent events, the probability of A and B is the probability of A times the probability of B. Suppose that you flip a coin and roll a die. The flip of the coin doesn't affect the die, and the roll of the die does not affect the coin. Therefore, they're independent events. So what is the probability gets ahead and rolls a 5? So again, and means times. What's the probability of getting ahead? Well, that's of course 1 out of 2 because there's only a heads or a tails. And time implies to multiply. The probability of rolling a 5, well, there's 6 sides of a dice and only one of them is a 5. So, and you can imagine if you want the probability of a heads, that's 1/2. But if you also have to get a 5, then the probability becomes less than 1/2, right? You have a less chance. So when you multiply fractions, you know you get smaller. When we multiply fractions, we just multiply straight across. 1 times 1 is 1. 2 times 6 is 12. So the probability is 1/12. It says give your answers both a reduced fraction and round to the nearest hundredth. 1 divided by 12 is 0.083, so we'll just 0.08 to round it to the nearest hundredth. Those events are independent, so with and we just multiply. So that's what you need to ask yourself. Does one event affect the other one? A U.S. roulette wheel has 38 numbered slots, right? If you've never seen one, they're numbered 1 through 36, but they also have these 2 green slots of 0 and 00, and that's the one that throws off the probability. They're 18 black, 18 red, and 2 are green. So if there was just a roulette wheel and there was no green, you would have the 50-50 chance of landing on black or red, but the green ones actually throw the probability down a little bit of getting a black or a red. So the ball can land on any slot with equal probability. What's the probability of a red occurring on 2 consecutive plays? So what does that mean? That means probability of red on the first one and red on the second one. So you know that you are going to multiply. So red on the first one is 18 out of 38, right? There's 38 slots because there's 18 red, 18 black, and 2 are green. And whatever you roll on the first event has on the first roll, or in this case, you know, they throw a ball out there and it lands in one of those slots. The fact that it lands on red in the first slot has no effect on whether it's going to land on red in the second slot. So the probability of red again is 18 out of 38. So you're going to multiply. Now, what I would do to make things a little easier, of course, you can just multiply straight across 18 times 18 and 38 times 38, but they are going to be very big numbers. What I would do is reduce ahead of time. You can cancel any numerator with any denominator, but you can see that 18 and 38 are both even. So 2 goes into that 9 times, and 2 goes into that 19 times. And same thing over here. You can divide top and bottom by 2. Because then, if you look, you only have 9s on the top and 19s on the bottom. So now when you multiply straight across, you know your answer is going to be reduced. All right, 9 times 9 is 81, and 19 times 19 should give you 361, and then you don't have to worry about trying to reduce that in the end because you reduced before you multiplied. Again, otherwise you're going to have to do 18 times 18, get a really big number, 38 times 38, get a really big number, and then reduce that. So it's definitely easier to reduce before you multiply. Suppose that the probability, or if the probability that South Florida will be hit by a hurricane in any single year is 5/19, what is the probability that South Florida will be hit by a hurricane in 3 consecutive years? So that means the first year and the second year and the third year. Not or, and. So you know you're not adding them. You have to multiply them. And it should be getting less if the more years you're taking into consideration, right? The probability of 1 year is 5/19. But to hit 2 years in a row, it's going to get smaller, right? Second year is still 5/19, and the third year is 5/19. Now, 5 doesn't go into 19, so none of the numerators go into any of the denominators. So when you multiply straight across, you know your answer will already be reduced. 5 times 5 times 5 is 125. 19 times 19 times 19, well, that will give you 6859. That's what's nice, is that you know that this is already reduced because these didn't reduce over here. So the probability of 3 consecutive years of being a hurricane is 125 out of 6859, which of course is a lot less than 5/19. What is the probability that South Florida will not be hit by a hurricane in the next 10 years? So if the probability of being hit is 5 out of 19, you know the probability of not being hit is 14 out of 19. All right, they have to add up to 19 over 19, and 19 minus 5 is 14. So the probability of not being hit is 14 out of 19, but it says for 10 years. So we would have to multiply this together 10 times, which of course means to the 10th power. And again, if you do this in one step in your TI-30X11S, you find 14 out of 19, you can put it in parentheses if you want, or you hit 14 divided by 19 and hit enter, and then you raise it to the 10th, or on another calculator, remember your exponent button might look like that. 14 divided by 19, you either put that in parentheses and raise it to the 10th, or you hit enter before you raise it to the 10th, and it says round to the nearest thousandth, so that's it's 0.04717, so the thousandth spot is 7, the number less after it's less than 5, so we keep it at 7. All right, you would multiply 14 over 19 together 10 times, but that just means to the 10th power. So if 2 events are not independent, they must be dependent, which means that the fact that the first event happened affects the probability of the second event happening. So this is actually a conditional probability. So the probability of A and B is still the probability of A times the probability of B, but you have to given that A has occurred, which might change that probability. You have to take into consideration that A already happened. Suppose that 2 balls are selected from an urn that contain 4 red balls and 6 green balls. So there's a total of 10 balls. Give the answer below as reduced fraction. Find the probability the first is red and the second is green. If the first ball is replaced prior to being chosen. So if we want the probability the first is red, of course this means and the second is green. So the probability the first is red is 4 out of 10. Times, because it's and, the second is green. Well, the first ball was replaced, so you still have 10 balls, of which 6 are green, because the ball is replaced. If the ball was not replaced in your second one, it would be a conditional probability. You would only have 9 balls left. Again, I would reduce before you multiply. It makes things easier. 2 goes into this, 2 goes into this, and the same thing, reduce the 6/10, and 2 will go into both of those as well. It's much easier to reduce before you multiply. So then you have 2 times 3 in the top is 6. 5 times 5 is 25, and then you'll know you'll be done. Otherwise, you can get 24 over 100, and then you would just have to reduce it. The second one says find the probability the first is red and the second is green if the first ball is not replaced prior to the second ball being chosen. So the probability the first is red is still 4 out of 10 balls are red. But if you don't replace the first ball, you have 9 balls left, right? But the first one was red, the probability the first is red. So you still have 6 green balls, all right? So you had originally 4 red and 6 green. So the probability the first is red and the second green if the first ball is not replaced. So the first ball was red, which was not put back in. So you still have all 6 green balls, but you only have 9 total. All right, you're missing that one. So this is what we're going to do. Again, let's reduce before we multiply. 2 goes into this twice. 2 goes into that 5 times. Looks like 3 goes into this twice. 3 goes into this 3 times. And then let's multiply across. 2 times 2 is 4. 5 times 3 is 15. And the last one says find the probability the first is red and the second is red if the first ball is not replaced. The probability the first is red, again, there's 4 out of 10 that are red, not replaced, so we're down to 9. But we don't have 4 reds now, we only have 3 reds. So this time there are 3 reds out of 9. Again, if it helps you to write out like this, 4 reds, 6 greens. The first ball was red, so the second one, there's only 3 reds left out of a total of 9. Okay. Again, we will reduce before we multiply. 3 goes into 3 once, 3 times. 2 goes into that, 2 goes into that, and then you multiply straight across. 2 times 1 is 2, 5 times 3 is 15. All right, we'll do one more of these. 3 people are randomly selected, 1 person at a time, from 5 freshmen, 2 sophomores, and 4 juniors. Find the probability that the first 2 people selected are freshmen and the third is a junior. So we want the probability the first is a freshman and the second is a freshman and the third is a junior. Not or, It has to be exactly all of those and. Give your answer as a reduced fraction, then round to the nearest hundredth. Okay, so we have how many total? 5, 6, 7, 8, 9, 10, 11. So there's 11 total people. The probability that the first is a freshman, there's 5 out of 11. Now, the second is a freshman. Well, the first was a freshman, so there's only 10 people left, and there's only 4 freshmen. The probability then that the third is a junior, you've taken 2 people out of the 11, so there's only 9 left, but there's actually 4 juniors because the first 2 were freshmen. So there's 4 juniors left. And again, if it helps you, 5 freshmen, 2 sophomores, and 4 juniors. So obviously the probability that the first is a freshman is 5 out of 11, and you cross that one out. Then you have 4 F's out of 10 for the second one. The second one's a freshman. So then you only have 9 left, but you still have 4 juniors out of the 9. So that's the third one, if this idea helps you. Remember, you can cancel any numerator with any denominator. The 5 and the 11 don't reduce, but I can do the 5 goes into 5 once and the 5 goes into 10 twice. And then I can actually cancel that 2 into the 4. 2 goes into 2 once, 2 goes into 4 twice. And in the numerators now I have 1, 2, and 4, and the bottom I have 11, 1, and 9, so there is no further reducing. But you can multiply straight across and then reduce later too if you didn't get it all at the beginning. 1 times 2 times 4 is 8. 11 times 1 times 9 is 99. So the probability is 8 out of 99, which you can punch that in a calculator. 8 divided by 99. And if you round to the nearest hundredth, that should give you 0.08. It's 0.080808, so it's 0.08.